Good morning, everyone. I see there's a few of you dragging your feet on these projects, and I wanted to kind of show you what it might look like when you join a Zoom and how you end up remote controlling the Finch robot. So the first thing we need to do is figure out where the assignments are and what's going on. So on our homepage, if you scroll down, hopefully you've gone through all these lessons. We're down to projects and the Finch movement remote access or lab required. So this is part of the assignment is actually remote controlling the robot with the code that you created. But let's take a look at how you might go about doing it. The first one, which is part A, is the Finch maze. The Finch maze, what we want to do is we want to make the Finch travel from point S on the maze to point E. And we want to do it in the least amount of lines of code. Okay, so we want to try to do it as quickly as possible with the least amount of lines of code because we want to be efficient. Okay, so down here, I have added the PDF file of the maze. So you can open that up and take a screenshot if you wanted something bigger, or you can take a look at this. And in this maze, there are some light green dotted lines. Okay, it's graph paper, it's a grid. And if we take a look at our key over here, each one of those squares is 10 centimeters by 10 centimeters. So if you wanted your robot to go forward 10 centimeters, it would be forward 10 centimeters to get to this point, forward 10 centimeters to get there. If you take a look, we can go there's 1, 2, 3, 4, 5, 6 blocks that we're not on. We could have our Finch robot go forward. 6 times 10 is 60 centimeters, and that would get us down to this point. We would end up zigzagging our way through the maze, which ends up going up this way down, and we end up at the end point, the end point. Okay. If we look at the camera view, I'm going to show you in a moment, you'll see that the S starts as far away as it can be up in that top left corner. And we are going to be traveling to the E, which is all the way down in the bottom right corner. Okay. The maze on that grid that I have for you that the robots are using, the blue path and only the blue path is the solution to the maze. You can see we come down 1, we go over 1, we come down 6 squares, we go over 3 squares, we go up 1 square, to the right 1, up, and you can see how we zigzagged our way through. So the blue line is the solution, and that is what I'm looking at with your robot to see if you can follow the blue line on the grid to make it to the E point. Okay, so that is what the grid looks like. That's what the robots will look like. And that is the path that you will be following or coding. Now you might go, well, how am I going to figure this out? Well, there's a couple things you could do. You could take this you could take that image into Snap, and you could code the little caret or the little arrow that goes through the maze. That's one way you could do it. The second way you could do it is just writing the pseudocode. So the pseudocode is forward 10 centimeters, turn left, forward 10 centimeters, turn right 90 degrees, forward 60 centimeters. So you could write out the pseudocode. When you have the pseudocode written out, that's when you would come to the lab or the live view with the robots, and you can put your code into the remote server. Okay, so once you have the solution, or how you're going to get through this maze, then you need to make an appointment with me or join the weekly Zooms. So that way you can put your robot on here and we can test it to see if it works. And if there's a mistake, like you turn right instead of left and it goes the wrong direction, well, that's where you can fix the code right at that moment and we'll do it again. It does not have to be perfect the first time. Both of the students who've done it so far, they spent about 20 minutes and the other students spent about 30 minutes, and they corrected their code as they worked their way through this solution. Okay, so that is project number one, and that is what it would look like. Now, in these projects, when you, at the end, when it's all done and your robot gets to point E, you want to take a screenshot of the code. And what I want you to also put on the code is a comment. And this comment is going to tell me that you understand what this code means. Code with a comment, then you're going to take a screenshot, put it into a Google Doc, and share with me. Now your code might be longer than this, and it might take 2 screenshots. That's fine. Snap will not allow us to copy and paste the code into a Google Doc. So that's why we have to take screenshots. But I want to see your code. Okay. Once you have that done, the video, I am going to capture that with Zoom, just like I'm doing right now, because that's one less window or thing you have to worry about on your Chromebook. Okay. But step number 3, you do need to do, and this is a video, and what you're going to be doing is you're going to be talking about the following topics. Explaining to me how you use the pseudocode or a flowchart, whichever one it works for you. And you're going to explain it to me and how it works with this project. And that's worth 25 points. You're going to discuss computational thinking. You're going to discuss decomposition, and you're going to discuss evaluation. As you did this project, you did those 3 things. If you, and these are all things we covered in the previous lessons. If you're not sure what they are, Google them, go to Brisk, it explains it to you, and you can ask the AI tutor to help you out, okay? But those 3 things need to be discussed with that terminology, okay? So computational thinking, this is how I used it. Decomposition, this is how I used it. Evaluation, this is how I used it, okay? That's worth 25 points. You're going to explain your code, which should be kind of a repeat of this, and your code's not very long. So if you did something unique, like use the repeat, if you turned your wheels instead of turning a direction, there's all sorts of different ways you could have answered this problem. So what you're going to do is quickly explain your code to me. Okay, and then the last thing is a reflection. What went right, what went wrong. Yesterday, the student I was helping, he got all confused with our lefts and our rights, and we ended up doing a lot of turns the wrong direction, and eventually we got it figured out. Well, they can explain what it is that the problems they had, and then how it successfully worked. Okay. And down here in the bottom is comments, and this tells you how to add this light yellow box to your code. Because some of you may not know how to do that. I do not believe it was covered in the tutorials. So here, it's a simple right click, and you can add comments. Okay, so that is the maze project. One thing I do want to note, camera view of the maze with the blue line or the blue squares that you're following, you will see some yellow squares with lines through them. Okay, that is part of the jousting assignment. And we're sharing some of the same squares. So those lined items are, the yellow squares with the lines in them are part of the blue thing. As you can see it, every blue square for the maze is a full square. And if there's something inside that, like a yellow shape, put some lines through it, just ignore it. Okay, that's the big gel thing that you're gonna be doing at the end.